as time goes on, and we are live on YouTube. Hey, everyone out there in YouTube land. Welcome to another edition of Jina AI's Engineering All Hands, where it's all Jina all the time, at least for the next hour. So 1 out of 24 hours, not quite all the time. But yes, we have Connor Shorten here with us today. He is going to give a wonderful talk about neural search. Before we dive into that, a quick intro of what Engineering All Hands is. It's a monthly get-together where we discuss tech topics and where we hear cool people talk. So we'll start with one of our chief engineers, Joan Martinez, who is going to give a quick recap of what's new in Jina. And yes, we have just promoted him to panelist.
Hello, so let me share my screen because I'm gonna quickly talk about what's new in Jina or what has been worked on in Jina, the biggest highlights of Jina for the last month, more or less. So the first thing that comes to my mind, and a feature that I think a lot of our community would love, is this new data class feature that has been there from the last release of Dockeray. And this feature allows anyone to reason about really complex data structures as a composition of different documents and document arrays. So the fact is, in Jina, we have always understood that document array is a great fit for reasoning about multimodal data and data of different types. But this knowledge we were not so good at transferring to the community, because a lot of times the community was asking, how can I represent my type of data in this sense or in this other sense? And thinking about this and knowing the power of data class, that is this new feature that was released in the latest Python's versions, we thought that it would be useful that instead of fixing everybody to the schema of a document, we could allow the user to develop and to reason about their own schema as in a data class, because people are used to work with data classes. And under the hood, we would build this complex document array structure for them to use. So the point is, with this feature, you can structure your documents and your objects as you want. So a composition of images, text, subtext, or whatever. And at the same time, by being super intuitive for you to your own specific use case, you can enjoy all the nice features of traversing and so on, and all the power of document and document arrays. So I think it's something that I would recommend everybody to use, that if they have a use case where they handle multiple data at the same time of different types, and I'm sure some improvement will come in the next times, but I'm sure you will all enjoy a lot. Then another big thing that has happened recently in Jina is 1 hour ago we released the latest Jina version 3.3 of the core repo, and one of the biggest changes, it's a breaking change, but it's a good change, is that we have get rid of the head bot for deploying executors. Why? Because when we were trying on our own on one of our products that we are developing, we were seeing that we had an extra deployment in our cluster for each executor, and that was exhausting a little bit about resources. So it was not so cost efficient in terms of deployment, especially in Kubernetes. So what we decided is to go one step further in our cloud nativeness, and right now we are just assuming that there is a service mesh between the gateway and every executor, and then everything is much more natural. The breaking change is small, because the only thing that is needed now to keep working is to install a service mesh in your Kubernetes cluster, and then everything goes smooth. But this you should feel also some better. It's not a big improvement, but some better performance. But definitely there will be less entities in your cluster going around. And then another big thing, conceptual big thing that has been developed or clarified in this latest release is the usage of executors as a standalone objects. So in the, I don't remember if it was 3.2 or 3.1, we added this option to serve executors as a standalone objects. And this was just syntax sugar around the flow. So when you say an executor is served in a standalone mode, is that we are building under the hood a flow with a single executor. But it's not always it is not always true that you need to have a gateway in front of an executor. And for this, we have clarified these concepts of external and shared executors, and we have clarified how you can develop, how can deploy an executor in the cloud by using these two Kubernetes YAML object conversion methods, and with the option to add the gateway or not in order to be shared by multiple flows or to be served outside with all the gRPC, HTTP, WebSocket power that our client provides. And then one of the biggest news, definitely one of the biggest news that has been happening in the last times is this Clip as a Service project that we have released really recently. This is a direct consequence of Bird as a Service that was developed by Han. And this is by taking all the power of Jina ecosystem, Docker Array, Jina Core, everything, we are allowing you to serve a clip model that can encode image and text in the same embedding space in a standalone mode and can be accessed via gRPC, HTTP, and WebSocket. What are the features? The features that Jina Core provides and allows you to use is fast, it's elastic, it can scale, it's easy to use, and it can allow you to use gRPC, HTTP, or WebSocket with a lot of all the features there. So yeah, I think I have been brief enough, and these are the highlights of the last month and the development in Jina, but much more to come. Thank you.
Awesome. Thank you, Joanne. Yeah, if you want to keep up to date on the latest Jina development, you can go to our blog. We're now on medium.com. We'll share a link in the chat. And every 2 weeks, we're pushing out our Rewind blog post where we're recapping what's been new in Jina, in the Jina ecosystem in the past 2 weeks. So one of the other notable developments is we've integrated Elasticsearch with Docker Array. So yeah, you can retrieve embeddings really fast. Yeah, you can, as I said, find us on Medium, link in the chat. Right, I will now hand it over to Connor. Over to you.
Cool. First, let me get the screen share. All right, success with the screen share. Awesome. All right, well, first of all, thank you so much for inviting me to speak. I've been having so much fun learning about Jina AI and integrating it with Weaviate, and I'll come into the, the Weaviate integration with Jina AI, I guess didn't make the latest news list, but hopefully still something that's new enough to be, to open the meeting with. And I also have had so much fun using Clip as a service, and in this talk, I'm gonna do some visualizations of the Clip client and coding data and showing this kind of property of what you get from something like Clip compared to a lot of other kinds of models. And this particular phenomenon of robustness is what I really want to talk about. So the title of the talk is Understanding Robustness. And this initial picture kind of shows the phenomenon. So if you put this original airplane on the left into a CFAR10 embedding space, this is a ResNet trained to optimize CFAR10 class labels. You see, if you put the one in the left into the embedding space, you get all these similar airplanes. But if you just rotate it, suddenly you get all these cats. And, if you do any kind of augmentation, as I've been exploring, and as I'll show you in the notebooks in this talk, like adding noise, cropping it, flipping it, these can cause the retrievals to be like totally different. And that's not even just images, that's text as well. So I think it's, very important kind of phenomenon about this as we're building these vector search engines and we're thinking about like, how are we evaluating them? How are we just saying that this is a better vector search system than some other system? I think this robustness property is a very important thing to keep an eye on. And it's different from, I think, domain shift. And you often, when you look through the information retrieval literature, will see things like, oh, you've trained it on MS Marco up to 2018, and now you're asking it a question about COVID-19 and it can't answer the COVID question. And That's like the domain shift gap that they often use to describe that kind of phenomenon. But this other property, I think, of just general robustness with label preserving transformations causing much different search results, I think that's another kind of metric that we should add to the bag as we, test these systems. So to kind of backtrack, so how do we evaluate deep learning models? Generally, we typically have like supervised learning where we have annotated labels. We have train test data splits where, the test set is from the same data distribution as the test set, as the train set. And then we have metrics like classification accuracy and things like that. So an early work I was doing before I was, before I met Bob and became really interested in vector search is just seeing, getting into this problem of corrupted test sets and how that changes the accuracy. So on this image, you're seeing original CFAR10 images, then 50% crops. You see like in this ship, it's pretty much retained the ship, but 50% cropping is even pretty extreme in this case. I think it's a minimum 50% cropping. Anyways, and then Gaussian noise, adding this noise, and then 45-degree rotations. These kind of label preserving transformations cause this degradation in the accuracy. When you test it on these, even just predicting, deer, ship, truck, it can no longer do it if you do this distribution shift where it's it's label preserving transformations, but still it can't seem to recover from that. And I think that's one of the most interesting phenomena of deep learning models generally. And as we come back to clip as a service, this kind of zero shot models, one thing that they do much better than say training it on your own small data set is this property of robustness and not falling apart with these distribution shifts. So kind of to step back also and kind of cover the whole range of this phenomenon of distribution shift from say, label preserving data augmentations to negations in text, like other domains, this kind of idea. Maybe start off with this example. I think this is like one of my favorite slides to show people when I'm talking about deep learning is you have this original ImageNet image, and there's this adversarial optimized noise map that you add to it. And now it predicts the wrong class label, but with high confidence too. Like this adversarial noise map can throw it off so much. And I think it's just a very interesting phenomenon of deep learning models that I'm sure most of you are aware of. And then, so coming from that, where that's like adversarial optimized noise, it's not really a realistic thing you would see. You wouldn't have a self-driving car that's driving around and all of a sudden you have an adversarial optimized noise map has been added to the stop sign so the car doesn't see the stop sign. But more commonly, you'd have like these natural distribution shifts. And so I love this paper, Benchmarking Neural Network Perturbations, Common Corruptions, and Perturbations, where they have these 15 different augmentations, Gaussian noise, snow, contrast, and this makes up a new benchmark that's being used in papers like AugMix and AugMax to kind of benchmark how well these models are improving with this kind of robustness to natural distribution shifts like data augmentations. And then one other kind of thing is say domain transfer, where I think this gets really interesting when we think about from images to text, because in text, when we talk about domain transfer, we mean things like say the MS Marco, it's been trained on the Bing passage retrieval, and now you're testing it on COVID question answering. And you kind of say like, well, obviously it can't do that. It doesn't have the information. And in images is a bit different where say the domain shift is like the style of the images. So you see how you still have like the class labels from ImageNet or CFAR, like airplane, axe, ball, but the style transfers from sketch to photorealistic image. And this kind of distribution shift will also throw off the classifier. Having this kind of shift from classifying sketch drawings to classifying clip art could be a problem with robustness. And so to also just kind of bring this back to natural language processing, because I think like images and text are the two things that I'd like to focus on the most. You can see where you insert these things like negations and it doesn't get the, it doesn't correctly respond to the negation. And that's one kind of robustness test. You have this collection of all sorts of robustness tests, whether it's negations in front of important things or whether it's swiping out named entities. You generally see this continued problem that I'm hopefully showing you about how like if you do these kind of shifts, the model won't be able to keep up with it. And we can kind of control the shifts and we can study this to isolate the behavior of the models. So then kind of just connecting this a little further with robustness and domain transfer to make it pretty clear how these are two different things. Domain shift, this is the BEIR benchmark. I'm pretty sure this is the most popular benchmark in diverse information retrieval. And you see how you have things like the Trek news articles, core question pairs, or like fever, factual information like claim evidence pairs. And you have this kind of word overlap, and you might have like words and terms that have just never been expressed in certain documents. And I think that's kind of like a natural reason to make it fail. I think it makes sense why that should fail compared to where these label preserving augmentations and things, the way that makes it fail to me doesn't make any sense. So it's more of like an interesting question, I think, to explore is thinking about why these things cause it to shift. So now I want to point you to what I think is the most productive benchmark in deep learning right now. It's wild, a benchmark of in the wild distribution shifts. You have all sorts of different data domains, as we talk about multimodal and the data class, the latest update from Jina, you have these data structures to organize multimodal data. And you see here just like a stretch of the imagination of all the different kinds of data you could have. You can have, pictures, molecular graphs, you can have text comments, and then different domains and things like that. There's all sorts of data in this benchmark, and what they capture in this benchmark is this phenomenon of distribution shift where, as I'll show you in the next slide, for example, this Camelon 17, they have histology, image segmentation, and the drop in accuracy is 93.2% from the training domain. So that can still be train test split. That's 93.2% on the test split from the same data distribution domain. So these three hospitals. So, train test split on these three hospitals, and then you evaluate it on these held out hospitals. And due to just variations in the lighting and the populations, things that you really are very difficult to describe, it goes all the way down to 70%. So this is generally this phenomenon of distribution shift, one of the big outstanding problems with deep learning models and deep learning systems. So then finally, this is kind of my scale of distribution shift where I would say, it doesn't make sense to, it makes a lot of sense. The ideas of, say, natural augmentations or going from one hospital to the other, the negations or say named entity swapping, I think these are still like similar distributions to the training set. Like this is similar to different being like, it's a very different data distribution, and it would be surprising if the model did pass it. So like with MS Marco to COVID, I think it would be surprising to pass that. Similarly with these adversarial images, I don't think it's real, like it's such a different distribution to have an adversarial attack placed on the images. So this is kind of just a sense of this distribution shift, robustness, and this kind of general idea. So then finally, just to get a quote from some recent things, we're also seeing that this problem is class specific as well. So in this is a very recent paper, I think as recently as last week, the effects of regularization and data augmentation are class dependent. So basically when you do these tests, like you crop it to do the test accuracy, how much it degrades depends on the class. So in this particular quote from the paper, the barn spider class of ImageNet degrades from 68% to 46%, and how much it degrades depends on the class. Data augmentation impacts each class. If in ImageNet you have like 1,000 classes, CFAR10 you have 10 classes. Data augmentation impacts each class differently. Okay, so then to try to come back to search and how I think robustness can be important for search, it says like, how do we evaluate search models? And we usually have, say, like labeled pairwise scorings. We might have some ranked list, or we might have an annotated data set for, say, extractive question answering, extractive summarization, extractive fact verification, where in addition to the question, it's annotated with the paragraph that contains the information to answer the question. So we'd evaluate our information retrieval on, was it able to return that paragraph or not? But I think we can also kind of evaluate it with these heuristic rankings of how robust, how differently it returns queries, whether they're neighboring sentences or query passages, like the heuristics used in text, because it's not as easy to do label preserving augmentations in text, or say these data augmentations in images. And then one more time, just to kind of get this point home, is kind of domain adaptation and robustness. I see them as being two different kind of evaluation strategies, whereas domain adaptation is like, train on biomedical papers, evaluate on Amazon product reviews. It's like different, I think, than robustness, where it's just semantically similar inputs. And then when you're putting them through your vector search engine, are you getting much different results? And to what extent is that happening? So then to kind of even come back a little further into this general thing of vector search and how us as like a technical engineering community, how do we go out and communicate this to people who aren't familiar with vector search at all? Say, we have this kind of narrative where we're going from structured to unstructured search. And so structured search, we have these, symbolic descriptions of data, city, street name, bedrooms, bathrooms, square feet. You have these symbolic filters like number of bedrooms equals 5, and then you get all the instances with the number that has that exact symbolic match. So it's very correct with the current system of structured search, whereas with unstructured search, you'd say, drop in this image and be like, get me a house that looks like this, or some text description of the house, find me a house that matches this text description. And you can imagine with this picture of this house, say the way that you crop it returns much different results and things like that. It's kind of what I'm trying to illustrate with this general phenomenon of robustness. We want, like, if it's this house and it's like cropped, or it's raining or snowing, we still want to get like roughly the same results in our unstructured search. And then, so one more quote from Bob Van Light at Weaviate describing this transition from structured to unstructured search. Bob's quoted in this article says, "We represent a third wave in database technology," says Van Light. "Oracle's SQL dominance was followed by open source NoSQL databases pioneered by companies like MongoDB. Weaviate gives any enterprise the advantage of databases built with machine learning and deep learning at their core. The first use cases have been natural language ones, but we are also exploring images, videos, audios, and even esoteric cases such as graph or gene embeddings." So to come back to this, I think it's this transition from structured to unstructured search. And I think having some robustness in the unstructured search will help people kind of transition more from this symbolic matching in the SQL style systems and understanding more so what this kind of vector search system is. So now to come to the fun part about our Jina meeting, kind of the way that I was exploring these questions was with this combination of Weaviate and Jina AI. And this started credit to Laura Ham at Weaviate for presenting this notebook on how to connect to Weaviate and Jina AI. And it was so exciting for me getting to see these things. It really helped me get started with working with images, especially, and all sorts of things I'm learning about the Dr. A and the Jina Hub. And I'm very excited about this integration between these two things. So how I see Weaviate and Jina AI is it's a full stack neural search solution where I'd say the Weaviate is the back end of it with the database persistence and implementations of things like HNSW, fast vector search with symbolic filters as well. It's got that database layer, and then you've got the front end Jina AI layer with all sorts of cool things from Docker Array to these embeddings. So one other thing I really love about Weaviate is the Weaviate cloud service and how easy this makes it to set up, to network your database layer and to just spin this up. So for these examples, like, for example, I am persisting the CFAR10 clip embeddings by just, going into my Weaviate cloud service. You just click like, new cluster, name it, and then you're good. And then Jina also provides there's several ways to add data into the Weaviate cloud service. You can do it in Python through Jina, which is what I'll show you later. But you can also use, say, the Weaviate Python client or a command line interface to add your data into the database and then have it persist for when you, shut down the compute runtime or whatever it is. And then, so one other thing to promote the podcast a little bit, I thought this talk was very interesting between Yuri Malkov and Etienne Dillacker about the details of this HNSW search. And I just think it's fascinating listening to the technical explanation of this from, say, if you've taken computer science classes and you've seen, say, like Voronoi diagrams and you're wondering, like, when does that become useful? And this is like the expert level of taking that. And so I recommend this if you're curious about how you do this super fast vector search with HNSW and how that's implemented on that backend Weaviate database layer. And then further, I would just want to, say my general goal, something I would really love to see come to life is, I love Hugging Face data sets, papers with data, and say Kaggle, how they, put these public endpoints for anyone to get these data sets. So you just, click download and then you have whatever the newest data set is to play with deep learning. And so I really would love to be offering these endpoints for vectorized academic data sets. So we have the clip vectorized CFAR10, clip vectorized, whatever the thing is, like we can put these big models like from Hugging Face's Model Hub, the clip as a service from Jina AI, and then say OpenAI's embeddings API. We can put them through these things. Then we can put these in these Weaviate database backends and then serve the APIs for, if you want to do this kind of, say, like post-mortem analysis of the vectors, like this robustness testing. So I also highly recommend looking at this. This is an example of that. Wikipedia has been hosted, a Wikipedia vector search demo has been hosted on Weaviate for quite a while. Another kind of cool thing is it has the question answering model also put on that back end. So if you want to do question answering queries, like with the supervised learning model that retrieves and reads, that's also on the database backend. So hopefully that communicates that side of it. And now to kind of talk about some things I learned from Laura and how to connect Weaviate and Jina AI with Python. If you have, say you have your database, your data set is like a collection of files, and you have like JPEG files and they're organized in a folder, you can do it this way: document array.from files, you pass the data path, and then size is just 50 to test it quickly. And you just point it to the host point in your Weaviate cloud service. So I have the Weaviate cloud service CFAR10 new example. And then it, and then it'll point to that, and then it'll use this name image. And so if you're really using Weaviate, Weaviate has this class property thing where you say name it, like in Wikipedia, the name would be article. And then you could have meta information as well, like the date it was published, how many revisions it had, if it's Wikipedia, like what it links to. You can have these other properties in addition to just the unstructured data. as you're designing these, like semantic web, knowledge graph, all that good stuff for making it more complicated than just vectors. And later in the talk, I'd love to talk about like Jina AI's nested hierarchical embeddings and how that could tie with the overall semantic web style. I think is very interesting, but not something I've quite wrapped my head around exactly how to do it yet. And then, so if you don't want to just connect to the persisted database, you see how you just have, DA equals document array, storage Weaviate, and then the config where you pass it the host name to just, get it into Jina. So then just, the Jina AI doc array is what we're going to be playing around with on the front end. It has so many great integrations of things like when you're doing the search with .find, it has information retrieval metrics built in, and then, the extensibility with the, the hierarchical embeddings again, and the way that it is this unstructured multimodal data structure. So as, as said on the Jina AI doc array documentation, it's like kind of like pandas, but for unstructured data. And I think that's my personal favorite one for thinking about it. So, so then just to also escape this and show this, I was also really impressed with the clip as a service front end demonstration. I really like this. You can, so as I'll show you later in the code, Jina AI has clip as a service, which is awesome. You can, query clip and get the embeddings from it really easily. And you see this front end with Streamlit. And I think like you can build full stack apps with, with Weaviate and Jina and Streamlit, going from database layer to the front end functionality, and then Streamlit, you can build your full stack web apps, serve them across the world with, with this particular set of technologies. So yeah, and then one other thing I'm really looking forward to learning more about is Jina Hub and the executor flow, all that. And I don't have anything in this particular talk for it, but hopefully I'll be invited back and I can tell you what I've learned about the Jina Hub, because I think this is extremely cool. And I had the chance to talk to Maximilian on the podcast, and hopefully that'll come out soon. And just learning more about this, I think, is just extremely cool. And then also to say, I really hope you check out this podcast with Han Zhao. This is one of my favorite podcasts. I learned so much from this, and I hope you all really enjoy it as well. So now let's get into some of the code, and I hope that this code isn't too hard for you all to look at, but it kind of shows a couple of the things that I was doing to test robustness in vector search. And the very first one that I'm showing you is the least organized of the four. So if you hang in there, it'll get better than this. But so what we're doing is first we check the GPU, then so I just took the Keras CFAR10, I zipped it up into the folder to, and ignore this, to load it into Jina with the document array.from files, data path, and then you can load it in this way. And then you have your image database on Weaviate that's persisting, and then you have the host, and you've loaded the data. The way that you've gotten your data into Weaviate is through Jina's document array.from files, and that's one way to do it. And so in this first example, I was really just connecting Jina and Weaviate, and then using the PyTorch Torch Vision, the PyTorch ResNet that you just get off the shelf to just do this little pre-processing, just put the airplane in there, and then just visualize the nearest neighbors from the pre-trained ResNet that you get from PyTorch. So I didn't think this was very interesting, the pre-trained PyTorch model. So I went to use some models that I've trained myself in Keras. And so the syntax is a little different from PyTorch to Keras with how you integrate the models. Oh no, is this going to be? Okay, all right. So this one will look a little prettier with what I'm trying to show you with the robustness with the vision models. All right, so this is where you define your architecture code. We're going to be searching through the vectors that come out of this dense layer. So this model has been trained on classification, and then this is the penultimate layer of vectors that we're going to be using to embed the images and search through them. So we're going to use the image aug library to do the augmentations. We define the augmentations. In this case, we're going to use rand augment, rotate, crop, and noise. Here's an example of what rand augment would do to an image. Rand augment is a collection of like 15 different augmentations, and you have two hyperparameters, how many to apply sequentially and how strong to apply it, and then it transforms images according to that. And so so then what we do is we have the we load in, these are pre-trained weights from something else I was doing, which is why I did it in Keras instead of PyTorch, just to see what the status of this model is. You see when you evaluate it on these different test sets, when you evaluate it on rotate, it goes down to 50% test accuracy. Crop, it goes down to 72.8, noise 64, rand augment 73. So, and this is coming from about 82. And I'm sorry I didn't add that to this, but so it degrades about, say, 10% in the best case and say 30% in the worst case on just the raw prediction level. So if you're just looking at this at the prediction level, you see that it goes down. But now let's look at the search level and what these embeddings, how the embeddings are changed by doing this kind of thing. So wrapping all this in this little function where you just, all you do is you loop through the data set, and first you create an empty document array, then you just loop through the document, setting the tensor of the document objects to be the image, and then you do the training images.embed with the resonant vector model, and that will populate this embedding thing that this is a Jina doc array, and these are the attributes of the documents. So the embedding is what you use when you do Jina doc array.find. It's going to be looking for the embedding matching. So anyway, so we just, we use this function lets you pass in a list of augmentations. So say you want to pass in rotate, crop, noise, and then, you name them as well for this little visualization. It'll just, it'll embed it into the latent space. Then it'll use the database.find. Database is our Jina AI doc array that is connected to the Weaviate in the other example, but not in this particular one. And then you use the set overlap metric to see how many neighbors are shared and report that. So with rotating it, it really falls apart. So this is the augmented query with rotate. These are the original nearest neighbors before it was rotated. And then these are the nearest neighbors after it's been augmented. And this is the set intersection divided by the set union plus the set intersection. They only share 1% of their neighbors when it's been rotated. So I think this is an interesting phenomenon. Generally, you can test more augmentations, or you could also test different kinds of model weights. And hopefully that particular thing is interesting, even though I know this code doesn't look great. So now kind of coming into some of the clip stuff. So the clip as a service thing was super cool, and I had a lot of fun using this. So first you install the clip server, clip client. You connect to it with this C equals client, gRPC, demo, cast, Jina AI, 5100, 100. And then, so the first thing I was curious about is this idea of like using text embeddings for classification labels. So I was curious about these two ways of doing the label descriptions, whether you say this is an image of an airplane, this is an image of an automobile, compared to just airplane, automobile, bird, cat. And I thought that was a little interesting, where the short templates got a like 2.4% higher accuracy compared to the 60% with the long label templates. And so all you do is, so offline, and I know this is like not well organized, but in this thing, I was passing the entire CFAR 10 set through the Jina AI clip as a service. And I guess the only lesson I have learned from that to teach people, hopefully, is to like batch it like this. So you see how so this is like batches of 32, and you just kind of run it. If it's less than 32, then you either like clear out the cache, or you run your predictions and encode it and save it to the database. But you don't want to be doing this like one at a time, like one image to call the clip. And you could probably stretch that to like 128 or whatever as well. So anyways, the way you do classification with clip is you do the dot product similarity between the text embedding of the label and then the image embedding, and that's how you get the prediction. And then so similarly doing the image aug, defining the augmentations, and then so just rotating the image, and then we see the the original, these are the original nearest neighbors, and then these are the nearest neighbors to the rotated airplane in CFAR 10 from the clip embedding. So in both cases, we get very different neighbors, even with clip, from this kind of thing. And then maybe just one more example to go from images to text is, so from images, we have these augmentations like noise, crop, rotate that are like very obviously label preserving, whereas in text, it's more so like heuristically, and it's not going to be definitely label preserving. So what we're looking at with this is we're going to randomly delete one of these words. So we're searching through news articles. We have the Los Angeles Lakers win the 2022 NBA basketball championship. You encode it with the sentence transformers, mini LM, and then you get these articles. Then we're going to randomly delete one of the words. So here we've deleted NBA. We just have Los Angeles Lakers win the 2022 basketball championship. Similarly, we do the computation of the nearest neighbors with the augmented thing where we've deleted something, and they only share 47% of their neighbors. And then one other thing that I think is really cool, and I'll come back to this in the slides, is if you've been following these things like generative pseudo labeling or doc to query, they're using like generative models to augment either things in the document or the questions themselves. And I think generally this is an extremely exciting thing. So if you're curious about how to do this with Hugging Face transformers, they make it super easy to do model inference with something like a text generation model. So you do, text-to-text generator equals pipeline, text-to-text generation. You could also, as the argument, give it the model, and then, you know, on the Hugging Face model hub, you just give it the path to the model you want to particularly use. But just, I think it just will default to T5 base or GPT-2 when you just do the text generation at the ending. But with this, what you have is question like, what is 42? Context 42 is the answer to life, the universe, and everything. And it generates, you know, the answer to this kind of question. So the way that I was doing this to test it is you say question, what is this about? Context, and then you pass in the original string. So what is this about? And then it says the Lakers won the championship, that thing. And then it says NBA basketball championship is what this is about. And so there are all sorts of ways to concatenate the text generation with the original thing in like generative pseudo labeling. I think they have a document, they generate a potential question from that document. And then I think they're just concatenated like at the ending. So that's all I did with this. And then just again, you see if you concatenate NBA basketball championship and then the original query, now they only share 44% of their neighbors at 16. And I think generally it's interesting to see how like these, say, paraphrases of a query or adding additional kind of information to your query, how that can really change the ranked list of what you get from the initial dot product similarity between the query and the things you've searched through. So to kind of talk about this thing about robustness and maybe how it can be solved and what kind of things in the literature there are to help with this, one of my favorite is this paper, Robust Fine-Tuning of Zero-Shot Models. What this is showing is that as you have the zero-shot clip model, it's generally more robust. And this is particularly for, say, classification. And when you augment it with, say, rotating it, and then it's classifying, is this a ship or whatever? And so they have this, you know, this is this idea of out of distribution to in distribution fine-tuning. In some ways of, you know, having this weight space ensemble between the zero-shot out of distribution model and then your fine-tuned in distribution model, and then trying to have kind of the best of both worlds with the final model that you end up with. And then I really like this paper too, VL adapter, because what it shows is when you're fine tuning clip, you don't need to fine tune all of clip. You can just have, say, 4% of parameters that are sparsely put into the existing clip architecture, and then just fine tune those, say, 4% of the overall parameters of these things like adapter, high performer, compactor layers. That makes it so it's a lot more cost effective to fine tune clip, and then, you know, have the storage also you would have less weights you would need to store also due to the sparsity of it. So then one other thing I think is interesting is this idea of using heavy data augmentation to try to kind of cover a lot of distributions in the training set. And maybe that would work, is you can kind of have these things where you do this pixel-wise averaging, and now it's seen such a diverse data distribution that now hopefully it's more robust to going in those OOD points. And something they communicate from the paper is this idea of you have these standard kind of decision boundaries that say, you know, once you rotate this red, you end up in this space, and the model has no idea how to interpret this kind of space, compared to these kind of techniques that create a dense coverage of the space. And this is like a, you know, like a TSNE style visualization of that vector space. So then here's another idea that I've been working on is, you know, just trying to simultaneously do supervised learning and vector representation learning. And so in this case, not only do you have the KL divergence between the prediction of ship and like the one hot encoded label where the one is at the index of ship, but you also have a KL divergence between the intermediate vector representations of original and augmented images. And we found that this increased overall performance and, you know, is especially good for this kind of robustness. The distance between images and their augmented counterparts is improved a lot by drilling deeper into the representations with the loss functions. So then kind of really stepping back from robustness into something that I think generally, as we're thinking about generalization and evaluating deep learning, this idea of compositional generalization is something that I think is very interesting, and this idea of like symbolic functionality that's missing in neural systems. And so I want to pick a couple of things from DALL-E 2 that I thought were like fun to look at. The first of which is, you know, AI good at generating penguins, bad at counting, from Rachel Metz, you know, 4 dancing penguins. And you see how they're like photorealistic penguins, but it doesn't consistently generate just 4 of the penguins. It like ignores that kind of symbolic part of the 4 dancing penguins. And then, you know, also with this, you know, deep learning is hitting a wall, the Twitter fighting about that. This is kind of the argument, though, is, you know, compositionality is the wall that's Gary Marcus is arguing about. And you see when you have, say, a blue cube on top of a red cube besides a smaller yellow sphere, none of the DALL-E images can quite capture the composition of these things. And it can't quite get this idea of a blue cube on top of a red cube. This kind of generalization is something that's still kind of out of reach for these systems, and is maybe something that's pretty important for this. And generally, again, from structured to unstructured search, I think having some symbolic functionality and getting that into the systems will further help people understand it. And even if it's not like complete compositional generalization, I think just having more kind of symbolic correctness will be good for this kind of search. So, so then just kind of quickly recapping the text things. This is the doc to query idea where you have the input document and then you generate some kind of query and you augment the data that way. And I think it's very interesting to be augmenting data this way. Generative pseudo labeling. It's a procedure where you take the original document, then you generate a potential question about it. Then you use the nearest neighbor search to get the negatives. And then you have the cross encoder with the original document and the generated question. And then the other sample documents that have a high, say, cosine distance or, you know, dot product similarity to these, to the query that was generated. And then prompt BERT, also just kind of this idea of like data augmentation in text to augment the inputs and then create a different representation as a result as it then goes through these models. And okay, so that kind of concludes the argument about robustness, and then maybe to kind of talk about some discussion topics and things that I think could extend this. So one thing I'm very interested in is re-ranking and how we have these, say, like cross encoder or pairwise scoring functions. And so I was thinking about how, like, to annotate, say you want to rank a list of 100 things, you have 100 choose 2, 100 factorial times 99 factorial, you know, divided by 2, that you have 4,950 comparisons you have to make to completely annotate an 100 choose 2 ranked list. So I think the kind of supervised learning approach for creating these re-ranked lists probably won't really scale that well. So having some way of doing self-supervised learning for this would be great. And so we have this data augmentation thing where, you know, we have the original ranking that comes out of the original model, or maybe even we take it from something like CLIP, and then we can augment it, and then we get a new kind of ranking, and then we can take the augmented vectors, and we have that ground truth of where they were originally ranked in the original list, and then we can use the IDs to match the corrupted vectors with the original IDs, and then use that labeling to self-supervise this and kind of bootstrap the task comprehension of re-ranking. And then, so I think another just interesting thing generally is, you know, like in Weaviate's HNSW, they add symbolic filters as well. So the use of symbolic filters and adding symbolic tagging to unstructured search is something that I generally just think is very exciting, even though I don't have like a completely concrete understanding of how this really works. But I think, you know, just adding these tags and adding all sorts of different tags. If you're looking for data sets with images, the, say, Celeb A data set has, like, you know, sunglasses, long hair, all these different symbolic tags. And I think symbolic tagging and neural search could be working closer together than they currently are. So then kind of just talking about the Weaviate and Jina AI, I thought it was super cool seeing the, you know, the front end of Jina and the persistence of Weaviate. I really love the combination of those two tools to study whatever questions you have with vector search and build vector search systems. But I really want to like learn more about how to use the nested structure of the doc array. For example, taking a big image and then chunking it up into the windows, and then having embeddings separately for each of the windows that then propagate up to the whole thing. Still trying to figure that out. And then say unimodal and bimodal embeddings with the CLIP, seeing how we can concatenate images and text. As you see with data augmentation, we can, you know, really stretch that and produce several embeddings and maybe get some kind of ensemble with that. And then further, I'm just really excited to be learning about Jina Hub and figuring out how to add that into the things I'm doing. And then just kind of, so just to get a picture of the full stack neural search, we have like our, you know, our new query processing. And these are things that, you know, Jina AI is really great at, and hitting the Weaviate vector index with, say, the different models that are, you know, you can encode the models as they hit the database layer. You can put the ResNet 50 or the CLIP into Weaviate and have it encoded as it comes into the persistence database layer. And then you also have the post-processing and then things like the applications like re-ranking, question answering. And you could put these on the database layer as well, but you probably want to bubble them up to the front end and put them into collab notebooks as we develop these kind of things. So generally, I think this is really exciting, seeing this collaboration of the full stack neural search and exploring these kind of research questions. So in conclusion, I hope that you find this interesting, this kind of metric for search robustness, and seeing what happens as we augment, whether it's our text with, say, additional information or our images with label preserving transformations, and seeing what happens with these return searches. And then I hope you thought it was an interesting overview of how to use Weaviate and Jina AI, and how you see the Weaviate database layer and the Jina AI front end and the doc array and all that kind of stuff. So thank you so much for listening to me talk, and I really appreciate you know, being able to come here and speak about these things. Cool.
Awesome. Thank you so much, Connor. That was a really insightful talk, and we've got a few questions. So I'm just checking which questions are for you and which are for Jina.
Okay.
Okay, it seems, yep. If you have any questions, put them in the chat or the Q&A section. So a few questions have come up about Jina, so we can have our engineers help out on that front. So one of them, a question from YouTube. Shards are used to partition big indices or segment large texts into smaller chunks. I'm very confused about what shards do, says YouTuber. Can anyone enlighten said YouTuber? So yeah, Joanne or one of our.
What was the question exactly? Because I didn't hear it properly.
Shards do. They know that they're used to partition big indices or segment large texts, but
A shard in Jina core. Yes.
shards in Jina core.
Yeah. So
yeah,
shards are a way to distribute. So if you have a lot of data and you have an index, an executor that stores data as an index, for instance, a simple indexer or one of these, if you use shards, you can allow every small part of this data will end up in each shard. So it's a way to scale in the amount of data that you have, and it can also help at searching faster because every shard can do its own search in a small subset of data, and then you can regroup all these and re-rank them. So it's about splitting your index in different parts.
Okay, I hope that clears up your question, random YouTuber. I can't see your name from Zoom, but yeah, if not, feel free to join us on Slack at slack.jina.ai, where you can ask in our channel, our support channel, or better yet, post an issue to GitHub. I believe the appropriate place would be the Jina core repo, and we'll post a link to that in the chat. So a question from Vincent. Can we elaborate on the Docker Array/Elastic integration?
So as far as I know, so Elasticsearch has been added as a new document store, the same way, kind of following the same pattern as it was included with Weaviate and with Quadrant. And it's about, as far as I understand, it's about also leveraging the nearest neighbor search that they provide. And we might, some capability to do full text search, the inverted index style search might come also soon.
All right, very cool. I think those seem to be oh, okay, question for Connor. Yeah, can you share papers informing the robustness checks with CLIP or similar models? And will you share slides?
Sure. Yeah, let me organize it a little bit. I'd be happy to share it. Yeah. Cool.
Awesome. We'll put up a blog post later with a link to the video and the slides and everything else Connor wants to send us. All right, do we have any more questions from YouTube? I'm not seeing anyone post any, so I'm guessing no. So we will wrap this up soon. Just a quick thing that towards the end of the month, we are having, once again, having our office hours here at Jina. So the right tool for you. Or if you just want to drink, come join us. Myself, some of the Jina engineers will all be here on Zoom. Check out our meetup group, link in the chat. we'll be posting it there. We will be doing it at the end of the month. We're discussing maybe doing another one as well. So stay tuned. I think that's most of the stuff. As I said, our blog is now on Medium. We'll be posting every couple of weeks on the latest updates on the Jina ecosystem. So if you go there now, you will see a post on the Elastic integration, and that's also covered on our docs on Dockeray. All right, I see no more questions. So yeah, thanks everyone for coming. It's good to see some names out there. Some of them I recognize, some of them I don't. Dimitri, Ranjit, Vincent, Giancarlo again. I almost forgot to mention you, Giancarlo. I see you so often, you're part of the scenery. All right, and of course, thanks again to Connor for the awesome talk.
Thank you so much.
All right, bye everybody.